Hey guys, today we're going to be talking about adding and subtracting rational expressions. And as you kind of already seen, rational expressions are kind of similar to fractions. So we're going to start our warm up with looking back to how to add and subtract fractions. So if you had to add fractions like our first example, 7/20ths plus 9/20ths, you would see that we have common denominators. When we have the same denominator, we can add and subtract fractions. So 7/20ths plus 9/20ths is simply 16/20ths. Because when we add fractions with common denominators, we just add the numerators and we keep the denominator the same. Now, this one also can be simplified because 16 and 20 have a common factor of 4. So this would be reduced to 4/5 for our simplified answer. Now, we're talking about common denominators. Something involved with common denominators is the concept of least common multiple. The least common multiple of 20 and 45. That's almost like asking what would be the lowest common denominator of 20 and 45. Now, there's a couple ways of figuring this out, but just to illustrate this, we'll do it the long way, which is listing the multiples of these numbers. So I'm going to start off with the multiples of 45. That's 45, 90, 135, 180. Now, I'm stopping at 180 for a specific reason, because as I'm listing these multiples, I'm subconsciously ask myself, well, does 20 go into any of these numbers? And I believe that 20 goes into 180. Well, how can we verify that? I can list the factors of 20 as well. Or sorry, the multiples of 20. Starting with 20, 40, 60, and so on. 80. Now we're getting a little monotonous here, but we can see eventually we do get the same number. Now, we wouldn't have to list these factors out this way every single time. This is just to emphasize a point of how we can do the least common multiple on an elementary level. We can find it by just simply counting the multiples. 180 and 180 is the first time that 20 and 45 have the same multiple. This would be their common denominator if it was a fraction problem. Now, our last warm-up problem involves adding a fraction with not the same denominator, or unlike denominators. In order to add these, we would first have to make the denominators be the same. So you first might want to ask yourself, what is the least common multiple of 18 and 24? If you were able to come up with the least common multiple is 72, good job. So I got to change these denominators into 72. And when I do that, I'm going to change the numerator as well. I'm going to multiply my fraction over here, top and bottom, by 3. Multiply the fraction over here, top and bottom, by 4. This will allow me to rewrite the fraction as 20 over 72 plus 21 over 72, which would add to be 41 over 72. Notice when we multiply the same thing on top and bottom for each of these fractions. That's how you produce an equivalent fraction. Now, what happens when we actually get to rational expressions, like down here? Notice they still look like fractions, but now we have some variables and other things mixed in. So here's our steps. We want to add or subtract the numerators, keep the denominator the same, and simplify our answer. Notice that in our first 3 examples, and will be different on page 2, first 3 examples have the same denominator. So when it has the same denominator, we can just simply add or subtract. But again, we're adding and subtracting the numerators. The denominator should stay exactly the same. So that denominator is already going to be 2x for my answer. 3 over 2x plus 5 over 2x is 8 over 2x, because 3 plus 5 is 8. Now, we want to simplify if possible. In this case, we can. 8 over 2 does simplify to be 4. So if we can simplify, we'll simplify. Not every single problem we'll be able to simplify. When we subtract, notice in this problem, there's a subtraction symbol. Now, some people forget that this subtraction symbol does apply to each one of these. So sometimes people like to change the sign next to each one of these terms, just to remind yourself that both terms are being subtracted, not just the first term. So my denominator is the same. Now I need to do my subtraction. 5 minus x and minus 1. Now, typically I would do this step like right in our head in one shot, but just to write it all out for our first time. 5 minus x minus 1. Notice that 5 and 1 are both constants, so that's the amount that we should be simplifying. X is a variable, and it will not be simplified in this problem. 5 minus 1 is 4. Minus x just stays a minus x, and our answer is x minus 3. So notice the only change from 5 minus x minus 1 is we're combining our like terms of 5 minus 1 becomes a 4. Lastly, we have x over x minus 3 plus 2 over x minus 3. My denominator is staying the same. X and 2 are not like terms. So when we add them together, we just write x plus 2. And that's our final answer for that problem. Now we got to get into some examples where we don't have the same denominator. Now, going along with not having the same denominator is this idea of finding the least common multiple. Our steps are listed above. Now, if we want to find the least common multiple, we're going to need to look at each term